All right. Hey, everybody. It's the 9th of September, 9/9/24. This is Cardano Go Live Coding. We've been meeting here for the last few months to talk about Cardano Go development from a few different perspectives. We've got Blink Labs, Gimbalabs, and friends here representing like we do on Mondays. And we've got two more sessions today, the 9th of September, and next Monday, the 16th of September to kind of summarize what we've been working on so far and really set the stage for what we're going to do next. We're closing a chapter on the Fund 11 Catalyst proposal that started this work. But right before we started this recording, we were also talking about some of our goals that we'll continue to work on after this. And the big goal we're going to keep working on is building out a public course where people can learn Cardano Go development. And there's a lot to say about that, so I'm going to just pin that for now. Um, but basically, as we close this chapter, we're going to have a lot of raw material and a couple of really nice drafts of lessons that will be part of this course. But we're going to open a new part of our work and really start focus on that course after we close out next week. Where that leaves us right now is we've learned a lot together. Chris and Aurora from Blink Labs have given a lot of great advice to the Gimbalabs team, to the Andamio team, and other folks who have showed up just about how to use the libraries that Blink Labs and other Go developers are building. And then we've started to build stuff together and build out that course that I was talking about. And so what we thought what we'd do today is just take stock of where we're at, what libraries are most useful. We've spent a lot of time here talking about what Blink Labs has, and we're already ready to go with that in the course. But before getting to any specific updates about Blink Labs work, we were hoping just to get some updates on the Apollo libraries. So Apollo is a transaction building library written in Go that allows people to create interactions with the Cardano blockchain. That's what a transaction is right? It's the primary way of interacting and changing the state of the chain. And we've been a little bit hit or miss with Apollo. I know that it's a project with one lead developer on it. Ed is brilliant, but also like a lot of brilliant people, busy. So we've been learning Apollo, but we've also faced a few blockers. For example, with deploying reference scripts and some of the other newer features that are starting to roll out. So Chris and Aurora, I know you've been spending more time with Apollo lately. How are you finding the state of those libraries and how reliable is it right now as we, in terms of being ready for Plutus V3 and ready for the Conway era?
Yeah, so in the current state, it is definitely not ready for the Conway era. It's being worked on, and that's what Eduardo is working on currently. He has it working with the Maestro provider. With the Block Frost provider, there's still some issues. That's what he's currently working on. And this is the main reason why it's not merged is because he has multiple providers now, and he has he's trying to get all of them working basically before merging the code. And then there's also like the null provider, which is the one that we use for most stuff, and the requirements for the null provider have changed
Mhm.
because the requirements for Conway have changed.
Right.
Conway requires you to include fees for the byte size of the reference inputs, right? So, but you don't know what those sizes are from a transaction. Transactions just give you the hash and position right within a block for a transaction. They don't actually right give you the size of it or anything. So now any kind of like event based or anything that's just based off of the transactions now has to have some kind of lookup table to be able to look up the previous ones. So in the case of like a null context provider, like what we use, you have to provide that lookup function now to the provider. So you have to stub it out, put something in it, right? Like, and in our case, we've got to put our data in it that we need. But it's still much more of a manual and handheld process. So it works in some cases, it works in some contexts, but still Block Frost is broken, and we still have some work to do in one place in Bluefin to update and add the context stub.
Who maintains the null context provider?
Well, the null context provider is empty. So no one maintains
Oh,
it
this
because
is
it's
just
empty.
right. This,
It's
oh, yeah,
null.
yeah, yeah, yeah. Sorry. This is a play. This says, right. Okay, this says I'm going to do all of this stuff by hand now by
Yes.
saying we're not providing the context. Okay.
So
Yeah.
it's not completely empty. It has hard coded protocol parameters in it, and then it just can't like look up UTXOs or do
Yeah.
any other like script calculation like the Block Frost provider can do by using those third party APIs. So
Right.
it has no back end. So it can't do anything that requires a back end
So it's
with it
not right
yet.
to call it a provider, but you're still keeping the protocol parameters updated there.
Yeah, no, I mean, so it is a provider. It's just a provider with no back end. So that's why the provider is null,
Yes,
right?
yes,
Because
yes.
there's a null provider. But as Aurora said, there is actually a little bit to it still. And now, the requirements of that have changed, right? So they've added a lookup function that you have to populate. But, the lookup function can do whatever you want. So we just have to, populate that information and add it to the lookup. Luckily for us, we know like for Bluefin, we are only dealing with 2 or 3 reference inputs, right? Like we're dealing with the Bluefin one or the tuna ones, and that's it. So we don't need a complex lookup system. We can know what the answers are ahead of time, essentially, right?
Right.
We
And it piggybacks on top of what we already had. It's just look up a UTXO by reference and return its bytes, which we're already doing for transaction building.
right.
And
So
but then once you have that, is that enough to meet the Conway requirements, or is there still a separate query you have to make?
nope, that's the only thing in addition that we need to meet the Conway requirements when dealing with a smart contract. So if you're not writing smart contract code, of course, Apollo works just fine
We're
if you're
good.
doing
Right,
regular transactions.
right.
And if you're actually doing Plutus V1 transactions, Apollo is fine still. Because it's not doing reference inputs, right? So
Right.
you're already paying for it because you included the bytes.
It's the size of the reference input. That's the part I
Yes.
wasn't putting together. Right, of
Yes. So
course.
now there's a fee, right, for the size of the reference inputs that didn't
Exactly.
exist till Conway. And so it's the fee calculation that's basically busted.
Right.
You can get around it various ways. One of the guys got around it by, literally submitting it, seeing it fail, and then adding a padding. So there's a
Yes.
there's a fee
I've
padding
done that. I've done that one.
yeah, yep. So there's a fee padding you can add, which is the approach that he took, and it works, right?
Yeah, yeah,
So
yeah.
it's that it works, but it's less good than it was before
Not ideal. Yeah.
until he gets everything worked out. So there's a branch you have to use, and it's yeah. So it's still a little bit rough, but I mean it works. If you dig into it, the out of box experience is not great at the
Yeah.
moment, but as you said, Eduardo is working on it. And this is his pet project, right?
Right. Well,
So
it's
it
always been clear he cares about it. Like I've never had
yeah,
any concerns about neglect.
right. No, I just mean but it's also a side project, right?
Yes, exactly.
it's not his primary thing. So we've talked, and like I've talked with him a bit. And I want to talk with him some more about trying to maybe help with some maintenance. Get him some help with it.
That was really the lead goal of this catalyst proposal that we put out there, right? But it's maybe a bigger scope than the way we said it in the Fund 11 proposal.
Right. So the
Okay.
state that we're at is, we've helped him fix and work out a lot of stuff between Andamio and Gimba and Blink Labs, to get to the state that we're at. But yeah, the recent hard fork definitely had some impact, right?
Yeah. Yeah. Okay, and so just to review that one more time, the Maestro is upgraded and working for Conway, and Apollo integrations with that are ready
In a branch.
in a branch, right? So they're not deployed on the main release of Apollo, but that's something that we can say like is done and it's coming.
Yeah,
Uh,
yeah.
Block Frost itself is not yet fully updated for Conway, and therefore Apollo is still building
Correct.
workarounds for that. Or
Correct.
just waiting on it. Is it better to say waiting on Block Frost or
I
building in
believe
spite
that
of it?
he's waiting on it. And
Yeah.
so the approach, if you're using Block Frost, is to, calculate the size ahead of time and pad
Exactly.
your
So you
fee.
might if you're using Block Frost right now, you might as well be using the null provider, because either way, you're going to have to do some workaround to calculate the cost of using the reference script.
Not really,
Not quite that.
because so well, it's going to depend on your usage, right? So if you're writing for like we are, where we know which reference scripts we're going to be including, you can just add the fee. You can just pad the fee, right? So we can add a fee padding that says, oh, it's going to be this much additional. And you could add that to the Block Frost context and the fees that it calculates. So you just end up adding the fee that it doesn't know how to calculate to it manually, essentially, right? But it's built into Apollo, the fee padding and all that stuff. So you can add that. But again, it's much harder if everything is dynamic. Right. So if you're building a much more general purpose system, then it'll definitely be a lot harder.
Yes. Yep, that makes sense. So we have a high level of confidence that these updates are happening, though, and it's
Yes.
pretty standard growing pains, especially for after such a substantial hard fork as this one.
Right, right, absolutely, absolutely. And once again, we are talking a single maintainer. So
Exactly. All right. No, I mean, that's a really, I think, optimistic update, and it's great. Like, so we know this is happening, and I think this is the perfect thing to report back to Catalyst stakeholders is, hey, like really, we did get a lot of things working, and we're also navigating this massive hard fork. So here's the status.
right.
Beautiful. Thanks. So now going back, like just to the Blink Lab side, I know there's been a lot of development, so it would be fun to just hear what's changed for your team and where priorities are at right now. But even before we do that, one of the things we looked at for several sessions here is UTXO RPC. How's the state of that, especially now moving into the Conway era?
Yeah. So I can kind of handle all of that a little bit together.
Great.
So our Fund 11 proposals were for Goroboros, well, part of Goroboros and for Cardano Node API.
Mhm.
And Cardano Node API implements both REST API, but also UTXO RPC. So we, up until before the fork, had UTXO RPC spec up to version 0.9. That has not just Go support, but is Rust, TypeScript, Python, Haskell. Is there another one? Anyway, I think there's another one. But multiple languages, and everyone is trying to stay together. So Cardano Node API is updated to that. There's a few errors in it, and they've already been corrected in the spec. And a new version of the spec either has been tagged or is going to. I actually need to check. I have no idea. Uh, because we should be updating basically, I think, today. If so, everywhere.
Congrats.
Second.
That's good.
Thank you. Let's see, where did we tag? Yes. Okay. So, it's tagged 3 days ago. Excellent. So yes, 3 days ago we tagged version V10, and that should support Conway and have all of the Conway fixes. That's been pulled into like Palace, so it goes into TX Pipe's Rust path, and it's going to be pulled into. It's already pulled into the Go Code Gen, and we're going to pull it into Ouroboros and push it out that way via UTXO RPC support in Ouroboros. So since Fund 11 started, right, since the beginning of this, we have created all of the Cardano Node API stuff. I'm going to skip the REST side because it's not exactly exciting, but we've built out the UTXO RPC side. We have been building out while TX Pipe has been building Dolos in Rust, and they have been building from a more product focused perspective, meaning they are building better support deeper into making things, more solid all the way into the feature set for like a single feature, right? In other words, they're building it as complete as they can and then moving on to the next feature. Whereas we went for breadth, and we're trying to cover the entire spec and maybe not support like everything perfectly in all of the filtering and that sort of thing. And then we're working on adding those after. So we actually cover the entirety of the UTXO RPC spec as far as 0.9. And we are working on now it'll be the next couple of weeks, we'll add the 0.10 support. That being said, most of the Conway stuff works. It's just some of the additional things like certificates and things like that that have been added post. The transaction submission, all of that sort of stuff should be working already in the spec ahead of that.
Thank you. Yeah, I still haven't used UTXO RPC to build anything, and I'm really eager to. Just to really get those patterns down, and we have some good notes. It'll be really good to have an example and a tutorial there.
For sure. Yeah, things are moving very, very fast with it in general. So it's a little hard to keep up. And one of the issues which we knew was going to be an issue that we've already planned for, but it's just at this point is a bit of growing pains, is UTXO RPC is a binary protocol that's versioned.
Mhm.
And so the client and the server have to match versions, which means that as we're talking about these different languages and these different implementations and things like that, it might be a little difficult to keep things working because of the different versions. So, like the current version of Dolos might be different than the version of Dolos that's deployed onto Demeter. So it might have a different version of UTXO RPC that might be different than the version of the Node SDK that you're using for UTXO RPC that might be different than, right? So there's
we have videos of us live navigating this.
Yes,
the archive.
yes,
That's great.
yes. So it's still a bit of a problem, but we tend to focus on just the Go stuff and trying to keep all the Go stuff working together. We're currently as part of our final milestones for Cardano Node API, we need to build an example app. And so we are planning on building that example app on UTXO RPC and using non-Go clients and things like that to actually build the example app, to essentially prove this out even further.
What's the perfect example app to build?
I have absolutely no idea.
Aurora, any ideas? This is a fun thing for us to dig into a little bit.
Yeah. So I'm not sure. In fact, I was looking at possibly figuring out how to port an existing app. So, we have a bunch of claims apps, like the Toasty Drop claims, those sort of claims. We have a bunch of claims apps, and they're pretty easy to modify. They have the front end and then a back end Express app, and the Express API is really, really simple, and it would be fairly easy to modify into using UTXO RPC because it does some things, like it actually does transaction building and things like that. So it would be interesting to convert that to UTXO RPC and try to get that information and use that for building the transactions.
Yes. And what
And then
I'm
sorry,
trying to think about how accessible that example would be. Like how much, what else does somebody have to understand? Like if we were to use an example like that in a course, what are the prereqs now?
Yeah, that's probably not a good. I mean, like building something like that would be okay. The probably the easiest examples would be, something that is going to build. Yeah, I don't know. I don't know. I mean, like the easiest things really are going to be something that deals with staking, delegations, because those transactions are generating certificates, right? Like governance actions, those sort of things. You're generating certificates. You have to generate the correct certificate, right? But my point is they're a well-known, well-documented state, right? They're in the protocol spec, for example, of exactly what they look like and that sort of thing, versus any kind of smart contract interaction, is dependent on the contract. The shape changes with every contract.
So
So
the
I would
first
say,
wave of examples being right, what's native to the chain itself.
right. Smart contract again. Then the answer to the app is, well, you're writing for the smart contract or vice versa, right? They're paired. Is my point. Is it's an on-chain, off-chain piece that are highly correlated versus, again, the certificates. So anything dealing with staking or governance or withdrawals or any of that sort of stuff is something that can be done pretty easily because, again, we're only dealing with the native chain primitives.
It's funny like this, it's funny thinking about this example in this moment because I've been sensing that because of now we have DREP certificates as this other kind of certificate. It's almost like people understand stake pools better. And we needed a second example. But yeah, more
Right.
generally, this concept of certificate issuance has now a lot of entry points for people. And the way you described it,
Yeah, there's like 17 or something like that new certificate types in
right,
Conway.
right. You better get used to using them. And people are talking about now using that kind, right? As of course, we talk about side chain implementations, partner chains, just the mechanism for defining a new certificate. It feels like people are now like really starting to sink their teeth into that.
Right. So yeah. Since also we started, and since we've started this course, we've built our Goroboros starter kit and
Mhm.
our Adder library starter kit, which show how to use Goroboros and Adder as examples. So we have example apps for that. They're made to be run in Demeter, but you can just run them yourself.
Mm-hmm.
Goroboros, we finished the server side support of Goroboros, meaning we now can speak the Ouroboros protocol in both directions. So we can not only ask questions, we can answer questions. We can serve as the server for other clients to ask us questions. And that is obviously a building block going forward for our Fund 12 project, which we've started of our Go node, Go Cardano node. And so that needs to obviously speak both sides, the client and the server of Ouroboros. And then also we're building UTXO RPC into it as a first class citizen. Like we are going to consider UTXO RPC as the way to really use our node and consider Ouroboros to be like legacy.
Amazing. I didn't fully appreciate that part before. Right, that UTXO RPC will be the primary communication channel.
In our case, because our node, we're building it for less of the stake pool operator block producer audience and more for the DApp audience.
Right,
So,
right.
right. So it's much more likely, that you would use it in a stack with the rest of a bunch of other Go things and that sort of things, or your other various ecosystem pieces. Uh, rather than necessarily using it as your only means of source of data, because we are optimizing it for data retrieval more than just block production, right? Like the design of the Haskell node, the Haskell Cardano node is for block production. Trade-offs that are made are for block production, right? You know what I mean? It's really designed specifically for that environment rather than for serving data.
Do you
And
need a bicycle, a pickup truck, or a cement mixer?
right, exactly that sort of thing. And even before we have like validation built in, like I would not say that you don't have any Cardano node in your infrastructure, but the point is a lot of infrastructure you end up needing to scale to multiple nodes.
Yeah.
Right. So if you have a single trusted Cardano node that you can use for, specific tasks like validation and that sort of thing, and then you fan out to these other nodes that are still capable of serving data, right, as a data tier to your front ends or your whatever, then you can scale easier because it uses far less resources because it does less work again, right? And it's not trying to produce blocks. It's not doing that work. There's a lot of work that is involved in all of the peers and chain selection and right, like resolving rollbacks and like a lot of this stuff that isn't necessary in a data platform where you're really looking for, you want the same data essentially mirrored out as much as possible so that you have a consistent view, right? Like you don't want it to work like a distributed system when you're talking about your own app,
Yeah.
essentially,
No,
right?
that
You
part
want it
comes
to be
through. You did such a good job explaining that at Builderfest, and like that part makes so much sense. It's like, how could we not provide these alternatives? It's
right,
it's
right.
thank you. Yeah, that's really good.
Yeah. So I mean, again, our goal is to move forward and trying to get as much of the protocol available for applications, so that you can embed applications. We want our node to be embeddable. So if
Yeah.
you're building a Go app, you will just be able to import our node as library, right, and use various pieces of it. If you want to have, like a simple connection manager without all of the peer-to-peer and chain selection and all that sort of stuff, you'll be able to use it. You'll be able to connect to a single trusted node and you'll be able to build a DApp on it. If you want to build like the full node, like we're doing, where you want it to operate as a network element, meaning it has multiple peers in both directions and, does its own validation for consensus and this sort of thing to like follow the right chain and that sort of stuff, we'll have that too. right? But the simpler case is you're just following a single peer and you follow it forward and backwards through rollbacks, but you just follow that single trusted peer. And that ends up being the case. That is the majority of how DApps are built, right?
Right. Well,
And the complexity comes in when they try to scale that, because they're trying to scale their infrastructure. And the as soon as you bring in that second Cardano node, and it's connected to anything other than the first Cardano node, right? Like you start getting into exactly a distributed system where the peers are different between them. And so the way to handle this is purely via topology, right? But then what you end up with is you end up with a replica, and the replica is doing a bunch of additional work it doesn't need to do because it is nothing but a replica, or at least that's your intent,
right.
right? And again, that's not exactly what the Cardano node is built for, right?
Right. Right.
So that'll be things that potentially we can look at, like clustering. Like these are some of the ideas of things that we might put into our node, is the ability to cluster nodes and have them be aware of each other, and be a trusted grouping of nodes, right? So, oh, I'm a DApp and I, need enough horsepower of, like, let's say 5 to 10 nodes for querying, that sort of thing. You can instead have, 1 or 2, and then have a second layer of data serving nodes on top of it, and know that it's all essentially serving the same data because you have a actual like replication protocol between them. In other words, we're going to make the ability to break and change the trust assumptions of the existing Cardano node. The existing Cardano node has 2 different assumptions. They have node to client, which means you're local, right? Or you're node to node and you're fully untrusted and you're remote.
Right.
And we're like, well, that's like, there's middle state too, right?
Right.
There's you're trusted because you're my own app.
Exactly.
But you're remote.
Right.
Not the same machine. So that's the area that really most DApps fall into.
Yes.
And so that's where we're targeting.
Hey, we need more horsepower, spin up. Okay, throw another node in there. Boom, that's easy. Okay, trust that one because it might as well just be the other one because we made it. It's
right. Well, I mean, when you do this stuff like Kubernetes, you just scale up a node, right?
Exactly.
Yeah.
Right. And then where does submit fit in? Would you separate nodes that are optimized for submit from the query ones, or can those be the same?
So we definitely would. And in fact, like we look at the way that you design this stuff as there's a read path and a write path.
Yeah.
And this is where like your classic more Web 2 kind of microservice-y design comes in. And this is also where like people a lot of times will make weird distinctions in their design. Is a lot of things have a very, very different read and write pattern. And one of the mistakes that many people make is they try to make one app do both. Right? Like, so they're like, oh, I have a user app whose job is to manage my users. It does both reading and writing. But those are 2 separate concerns, right? And especially with blockchain, like on the read side, you do validation just to validate that the data is the original data that was there. But on the write side, you do way more validation, right? In general, just because, you're validating that this, untrusted piece of information can be included on the chain, right? Whether it's a block or a transaction or whatever. So, like your validation is basically at max. But on the read side, that's not necessarily the case. And on the read side, you're reading what is essentially static data. It's been proven one time, validated the one time, and then is stored, and you're just retrieving that data. Now, whether you choose to do any validation of that data yourself is different, right? And you can choose the level of validation you want to do. So sure, if it's like a proof of some kind, you might want to rerun that proof to validate it. But that's something entirely on the client side that they get to choose. So the read and write path, my point is they have different concerns. Like the write path is, make sure the bytes that we are going to write, pass all of these tests. And on the read side, the real job is serve the bytes as fast as possible.
Right.
Right. And so that's where a lot of differentiation is. So I do suggest strongly splitting, essentially the write side, the transaction side, and the read side, because the read side is the side you're going to need to scale more.
Right. Oh, and that makes complete sense in the context of everything else. I like that. Yeah, I really like that.
Yeah. So in fact, like with the current Go ecosystem, the way that I would suggest building stuff is building your transaction submission in a way that you're talking to a Haskell Cardano node doing full validation.
Even maybe so even once the Go node is up and running, if it's easily pluggable into an app for all of the read operations, would you say even then maybe just use the Haskell submit?
So that's where it's going to depend.
Okay.
The reason why I say that is it depends on what you're submitting. If you're submitting, transactions that are built by a front end and the back end is, doing some kind of signing and submission, and it didn't build the transaction itself, and you see what I'm saying? So like
Yep,
it
yep.
really depends on what you're submitting. In some cases, you can absolutely submit it yourself, right? Because if you're talking about spending UTXOs out of your own wallet and this sort of thing, all you really need to do is check and make sure that the UTXOs still exist, that they haven't been spent, right? But if you're taking transactions from somewhere else and you're not spending out of your own wallet, you're allowing someone else to potentially spend out of your wallet, whether it be a smart contract or whatever, right? And you're trying to follow some kind of rules, then you're going to want a lot more validation on it. We plan on adding in and are working towards adding validation into the node so that it will be able to do as much validation as eventually the Cardano node. And in fact, we will be building that long before we build any kind of block production, because the transaction write path is a good path to scale out. And it is a path that can be potentially scaled cheaper than using Cardano node, right? Than using
Yes.
the
There's
Haskell node.
so much, right? I can see so many places where it would be so nice to have easier access to validation infrastructure.
Right. Right.
Yes, without a doubt.
Yeah. Yeah.
Okay.
So right now, like the easiest, or probably the easiest way to do that self-hosting is running Cardano Wallet. So now you're running Cardano Wallet on top of Cardano Node.
Right. Right.
Right. And I mean, and that's the easiest way to do it without submitting the transaction. the easiest way to actually check if a transaction is valid is to
submit it.
Yes.
Right. Excellent. Well, this all points to, I think, how we collaborate moving forward, right? Like we've been talking about it in some of our other collaborations. There's, I think it's worth it to minimize meetings as fun as these Mondays have been, but to continue on the shared goal of building out a course. A really nice pathway suggests itself. You guys already have the Goroboros starter kit and the Adder starter kit. Those, without too much additional input from your side, we can turn those into course materials. Hey, here's a starter kit. Let's play with it. Here's how to use it. And as additional development happens, I can just imagine a starter kit for embedding this read-only node into your application so that you can build quickly. That's another great starter kit. And then all that follow as the node development continues and as UTXO RPC comes online. But if we just kind of asynchronously have that pipeline of y'all pumping out starter kits when you're ready and us turning them into interactive lessons, how would that feel as just a way to keep this going?
Yeah, I mean that definitely is the right way to go about it for sure. One of the other things that would be interesting is something that would be definitely, let's say, a value add to these things would be building something that is a little more two-way interactive, where instead of it just being everything written in Go and you end up with, just a example toy Go app, adding a little bit more to it so that we are building a full app. So integrating, a front end with it,
Beautiful. Okay.
right?
Yep. And
So
that then speaks to connections even between courses, right? There's like a portal in a Go course that says, hey, here's an overview of this example application. To learn more about this app, here's some other resources, right? So we don't have to
yeah,
teach the whole front
yeah.
end transaction library. That's beautiful. Yeah,
Well, I mean,
that
and that's exactly it. Is so you could have, like, let's just say a mesh app or whatever, right? And it could be written and it could be written for the back end. And so the point is the instructions over in the, Go PBL are just, oh, check out this repo and run it. Not here's how you write all the code, here's how you do
yes.
everything. This
Yes.
is the front end for the app that you just wrote. Like, here's
Right.
the front end. Export these two environment variables or whatever and run it.
Right.
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 And then on that side, it's basically the exact same on the opposite side. It's like, oh, here's the, like app that's already built. You can just run it. And then here's how we built this app. Right. So that PBL of the front end side is building, the app for the
It's
back end.
just like the portal between Rick and Morty and Gravity Falls. Yeah, it really works out perfectly. We'll have
Right.
similar portals in these courses.
Yeah,
That's
absolutely.
fun.
So,
All right.
then you can cross them, and then we kind of start thinking about things together. Right. So it's like, okay, well, now do you have a PBL course where you're writing a smart contract and now you're writing a Go off chain for that smart contract. And now you're writing a mesh front end for that, or whatever, right? For that smart contract and for that back end. And now you have an app that is actually split into different pieces and the different courses are teaching those different pieces.
This is it. Have you ever talked to Hinson from Sedan Labs in any context?
No, I've not.
He's over there in Hong Kong and is actually teaching like a local course this previous weekend and continuing next weekend. Um, but one of the things he was working on, he was working on the Delta DeFi platform, and they really wanted to make some different assumptions to enable high frequency trading. And he built his own Rust library that has the same kind of architecture as Mesh, which is in TypeScript, but that allows for faster, more dependable transaction building closer to the Rust CSL, which is great. But then even with that in hand, he now took the Rust transaction building and calls it through a Go app, which he uses to orchestrate the whole thing because that's just the fastest way to do that. So it's been fun kind of seeing those examples. And he and I are working on different course material for the devs right now. So everything you're saying about how we connect this resource to that one, that's absolutely the top of his mind as well, because his goal is to train production developers, right? Not just, hey, use this platform because you want to, but to say, okay,
Exactly.
if you actually want to build an app, here's grab this from over here, that from over there, here's how it all works together. So I love that that's on your mind too.
Yeah, for sure, for sure. Especially because, even with our team, like we have skills gaps, right? Like we are back end developers for the most part, and we, don't necessarily have that skill set to be able to teach. So having the second side of it provided, by Andamio, so that we could also put other developers through that, so that we are able to, work both sides, front end and back end,
Yeah,
would be excellent.
excellent. That's a great path forward. That's really exciting. It's just natural. All these things are going to happen anyway. So now they fit. That's really nice. Um, very good. Well, that's all I've got today. Aurora, Adrian, Chris, anything to add? Cool. Chris G, thanks for the conversation. This is exciting.
Thank you.
I'll draft the closeout report for our Catalyst work and add a little bit of documentation to Andamio CLI. So we've got that. Next week at this time, we'll close out these Monday sessions and put a pin in when we're going to start getting back together. I think the reason to pick up live Cardano Go coding again is going to be that we announce that there's a public course. So we'll go on a little hiatus from running these sessions. We'll keep working on a course, but at some moment we'll say, oh yeah, there's enough of a course for us just to announce this thing is live and people should go check it out. And when we decide that, the Gimbalabs crew can think about when to host a live coding session, and it'll likely be the kind of thing where you don't have to be there. We'll have enough expertise, but it'll be fun to invite you sometimes just to go a little deeper.
Absolutely.
All that's to come. Well, thanks for an inspiring start to Monday. I'm always like trying not to break flow from the start of the week, but it always turns out to be worth it to show up here. So appreciate you for that.
Thank you. Thanks for having us.
All right. Y'all enjoy the rest of your Monday and see you soon. Take care.